So the central dogma model shows the process of getting DNA to RNA and into proteins through transcription and translation. The first thing that happens is DNA gets turned into RNA through a process known as transcription. In transcription, RNA polymerase must unwind and unwrap the double helix of DNA and separate it into RNA, which is a single strand. In order to do this, the RNA polymerase must break the hydrogen bonds that are connecting the nitrogenous bases of the DNA. Now, the main difference between prokaryotic and eukaryotic transcription is prokaryotic transcription, mRNA can just go straight to the translation process and it doesn't need to be edited or tweaked, whereas with eukaryotes, that editing stage is completely necessary and it can't be skipped. Once the RNA has been created, then it must go through translation in order to get to the final product, which is a protein. In order to do this, it needs to go through translation. Now, translation is a bit more complicated than transcription, just because there are more components and there's more things that could go wrong. However, it is easy to simplify and kind of break down for this model. So one of the biggest things to understand is that translation does not occur in the nucleus like transcription. Translation actually happens in the ribosome of the cell. So in order to get proteins from RNA, the tRNA brings anticodones to codons in the mRNA. The amino acids of those combinations of bases form a chain, which forms a peptide chain, which is just another name for protein. Now, the protein is the final product of the central dogma, and until it is needed for something else, that's really all there is. So to recap really quickly, the central dogma project shows the process of DNA going to RNA, going to proteins, through the processes of transcription, which requires RNA polymerase, and translation, which really needs tRNA and mRNA. Thank you so much for your attention.